All right, everyone, we're going to get started. Welcome to the July Crop Profit Grain Weather Webinar. This time around, we're going to do a little bit differently, and we're going to make some introductions to the team. So I'm being supported in the background, even though he's currently in the foreground, by Christian Bowen. Christian, will you take a chance to say hello?
Yep. Hello, everyone. My name's Christian. I'm the meteorological solution specialist here at Prescient Weather and CropProphet. I would just like to say thank you guys for joining, and hopefully you like this webinar and attend future webinars.
All right, thank you. And then last time we had questions being asked in the chat, which was my mistake. This time we want questions to be asked there's a question and answer section. And so feel free to ask questions there. And so Richard James, who is he's a company founder and one of the key science minds behind what's going on with CropProphet, is here as well. Richard, say hello.
Hello, everyone. Thank you for joining today. I am one of the founders of Prescient Weather back in 2009, a developer of CropProphet. So I'll be hiding out in the Q&A. Happy to answer your questions there.
Great. And then we also are joined by Josh Nagelberg. So Josh is on like his 7th day of employment here, but we brought him on board to help customers and prospects gain value from CropProphet. And some of you may hear from him after the webinar. Josh?
Well, appreciate it, Jan. Yeah, excited to be part of CropProphet here. I'm a meteorologist of over 20 years and looking forward to learning more about everyone who's on this call and potentially helping you all just improve upon how you grab your weather information and make decisions.
Great. Thank you very much, Josh. So we will get started here. Christian, can you just confirm that we're showing the presentation?
Yep, I can see it.
All right, great. So if this is your first time to this webinar, thank you very much for joining. We hope you get valuable information from us. If you were at the June webinar, thank you for coming back. And we hope this one creates as much value for you. And I was very pleasantly surprised reviewing the registration list at how many current customers are registered to join. Hopefully you're on. We thank you for your support. And again, we are honored that you're willing to join and hear what we have to say about the current grain weather situation here in the United States this summer. When we met in June, we reviewed July and June to date. We reviewed May and June to date. So we're going to skip May. Sorry. I have to take a step back. I do want to highlight that we continue to do the forecast discussions on YouTube. So on Fridays, we use the World Climate Service and its probabilistic long-range outlooks to highlight what the likely ECMWF medium range forecast is going to be for the United States when you show up in the office on Monday. And then on Mondays, we review what the forecast actually is. So the goal is to create a forecast of the forecast to get you ready for your trading week. And so search for CropProphet on YouTube and you will find us. So we're going to talk about June and July precipitation. We'll talk about June and July temperatures, discuss its impacts, and then we're going to take a look at the forecast by the end. So for June, the key statistic is in the lower right corner. The average corn crop received 124% of normal precipitation in June. The average soybean crop received 122% of normal precipitation in June. We see widespread above normal precipitation with some notable holes, particularly northern North Dakota, and then in the northernmost counties of Illinois, where some of the most productive counties in the country are for both corn and soybeans. Fast forwarding to July through yesterday, we see some drier areas have certainly emerged, but we still see the corn production weighted statistic is still 124%. And so clearly that is generated because of some areas with extensive excess precipitation. And so again, in the last it'd be about 15 days, we see dryness across the northern portions of the corn and the soybean belt, certainly dry in the eastern corn belt and dry in the southwestern portion of the corn belt, with really an amount of precipitation in Iowa and northern Illinois that those areas have not experienced in the last several years. So there was an interesting event just a couple days ago across Iowa and northern Illinois. And so looking at the total precipitation amounts by county, we see precipitation totals ranging from 3 to 6 inches. And so we thought it was interesting. There was lots of discussion, particularly on social media, about whether this was enough rain to damage in particular the corn yields in these regions. So we wanted to do what we do and take an objective look at the data to see what's in the data, which is to say we didn't want to speculate about whether or not there was yield impacts. We wanted to actually take a look at the data and try to come to our own conclusion. So to do that, we compared the precipitation events that have occurred in the past relative to the end of season yield. And so just to highlight the timeline that we're talking about, we're using the last 14 days for Iowa. And in this case, we're looking at Iowa corn production weighted precipitation. And we see that the substantial rainfall occurred from about the 6th of July to the 12th of July. So we're going to use the last 14 days. And we can take a look at county level percent trend deviations. So this is the percent of yield relative to the technology trend as a percentage compared to the maximum 14-day accumulated rainfall periods from 1981 to 2024. So to be clear, we're adding all counties in Iowa into this analysis. And so what we see, it comes as no surprise when it's really, really dry, when there's 1 inch of rain, when the maximum amount of rainfall over a 14-day period is 1 inch, it's a dry period, yields are very low across Iowa counties. We see that when rain is near normal, say 4 or 5 inches, we see near normal yields. And then in this case, there seems to be a signal that very excess precipitation generates negative yield returns in July. Notice, however, that there's this band around -40 to -50 bushels per acre. It turns out all of those dots are from 1993. So that is, it was an exceptionally wet year, all growing season long. And the point is that there was yield damage done before the month of July. And so we actually removed that data set. We removed the year 1993 from this analysis, and we end up with this type of graphic. And so the red dots are the average, it's the median of the result within a 1 inch bin. So go down the line in 1 inch bins, and that's the median result. So I mentioned that the counties in Iowa were somewhere between 3 to 6 inches of rainfall over a 14-day period. This chart would suggest that there was not a negative yield impact on those counties in Iowa, or even most likely northern Illinois. And in fact, the chart also suggests that even though when you get above, say, 9 or 10 inches, there's only a few dots, right? It suggests that exceptionally heavy precipitation is exactly that. It's exceptionally heavy. It doesn't happen very often. And so that is one event in history that caused those events. So we can't really say how much rain does it take in July for yield to be negatively impacted. But certainly the event that just occurred in the past 2 weeks is unlikely to be negatively impacting yields. Certainly locally, if there was, again, 15 inches of rain, 20 inches of rain, that may have impacted yields. But on a statewide basis, there's unlikely to be significant impacts. So then reviewing corn over the prior 90 days, if you may remember during May, we were looking at that dry section there in May and wondering what the rest of the summer is going to look like. Well, the dry deficit, or the deficit in precipitation that occurred during May, has dug itself out, and we're now at a substantial amount of rainfall across the U.S. Corn Belt. And we've seen in the news, everyone is talking about it being a very good year in terms of yield, and it's because of statistics like this for why that is occurring. So, and I'll just highlight the soybean as well. Looks very similar. So if you look nationally, the production areas for corn and the production areas for soybean are very similar. So when you do national corn production weighted statistics, you can almost replace them one for one with each other. When you get down to the state level, you can't necessarily do that, but the results are always very similar. We looked on that map, and we saw some dryness in the Eastern Corn Belt. So I'm showing here the I states. So this is the same chart. It's the 90-day, in this case, soybean production weighted precipitation over the prior 90 days. going from west to east. Iowa, currently in mid-July, is above normal precipitation by the end of the 90-day period, whereas Illinois and Indiana are now at below normal values. And so just to highlight, from a soybean production weighted perspective, Iowa's at a 1.63 inch surplus, and then Illinois and Indiana are at about minus 0.6. One of the things that is unique, or one of the things that is interesting, is looking at the graph, the map in the lower right. The dry over the prior 30 days in Illinois does include 3 of the most productive counties for corn in the United States: McLean County, Livingston County, and Iroquois County. McLean is the single most productive county, and the other 2 are in the top 10 of U.S. corn producing counties. So 3 of the most productive counties are certainly under a dry risk. It's also been warm there as well. So we can take a look at the drought status. So I like to look at the evolution of a corn production weighted drought index across the United States. In particular, I like looking at the evolution to see what direction the drought is going. We see a recent maximum in November of 2024. And so the corn production weighted drought index, which is an estimate of like how much of the corn is under different categories, or more importantly, what is the average category that the U.S. corn crop is experiencing, has been declining through time and really is not a risk this summer. On the left-hand side, we've calculated the percentage of the corn and soybean crop in different categories. And so for soybeans, there's no crop in extreme drought or exceptional drought. And for corn, we see a total of 0.9% of the crop is extreme drought or greater. So on Thursday, tomorrow, there's going to be a release of the U.S. Drought Monitor. And so one of the things that we did that we thought would be interesting to take a look at is, for the categories we just looked at and for the areas that are in the different categories as of last Tuesday, we wanted to take a look at how much rain fell over the report week. So the U.S. Drought Monitor releases tomorrow. They do an assessment on Tuesdays using data through last Monday. So the Monday of this week is when the data was through, and that's what we've calculated how much rainfall fell in each of the categories. So we see the corn exceptional drought regions, which was a couple of counties or a small handful of counties in Texas and California, received 160% of normal precipitation over the last week. We can expect those regions probably to decrease. The extreme drought regions for corn received 101% of normal precipitation, so there'll probably be some reduction in the extreme drought categories. And then if we flip to the other side, interestingly, the abnormally dry only in both corn and soybeans received around 82 or 83%. We might actually see an increase of the regions of abnormally dry, or they might bleed into becoming a moderate drought region as well. So certainly we produce this analysis because the market does look at the U.S. Drought Monitor as a proxy for information about yields. And so we're trying to quantify what those impacts might be. So let's take a look at temperature. So for June temperatures, we see broadly warmer than normal temperatures. Corn production and soybean production weighted temperatures were 2 degrees above normal. We see a little bit of cooler than normal in the western, northern, and southern Corn Belt portions. And the hottest part of the Corn Belt was in the eastern Corn Belt, particularly eastern Ohio, western Pennsylvania, where temperatures were between 4 and 6 degrees above normal for the month of June. Looking at July, the folks in Texas probably are happy to have cooler than normal temperatures compared to prior summers. The heat in the east strengthened, areas grew stronger, and then again we see 2 to 4 degrees warmer across broad areas of the Corn Belt. Importantly, we see the western Corn Belt, because of the influence of that cold pattern in Texas, where either was very near normal or even colder than normal. So not a significant amount of severe heat other than in the eastern Corn Belt where there was some dry conditions. And so if we look at the 90-day corn production weighted temperature, we see number one, the gray line in the middle showing climatology, that as of roughly today, we've reached the maximum climatological heat period. So temperatures generally cool from here. We also see the heat wave that the growing regions experienced in late June. But even that on a corn production weighted basis, we see was around 82 or 83 degrees. So it was hot. And I talked to people around the Midwest that were telling me how hot it was. On a national basis, though, it probably wasn't terribly significant because of the time of the year. However, we can look at the same statistic here. And what I want to highlight is that we're looking again from west to east, is that the duration of the event was relatively short in Iowa. And as you went further east, the heat wave became longer. So where it was a 1 or a 2 day event in Iowa, by the time it occurred in Illinois, it was maybe a 4 or 5 day event. The gray envelope here that we show on this chart is the observed 90th percentile envelope of observations. And so in this case, where we're above that gray envelope on the warm side of the curve, that's the outer 5% of the observations. So we use that to define whether or not the event is extreme. So certainly this was extreme. It was 5 days long, which there certainly have been longer heat waves. We'll talk about the forecast about whether or not we might see another one before the end of the month. So we can certainly talk about crop progress. We talked about it in the June event, in which the cooler temperatures that occurred in May likely impact some of the the percentage of emerging on a US basis. But really, if we take a look at weather and its impact on the crop progress reports, during this time of the year when we're looking at emerge, silking, and doughing, weather has a pretty muted impact. So what these charts show is the number of days it takes for the US crop progress reports to go from 25% to 75% crop progress versus the average daily temperature or the accumulated precipitation that occurred during that period. And what we see is, particularly in the silking phase and in the doughing phase, we see a fairly muted response to temperatures for sure. And overall, compared to planting and harvesting, we see a muted response relative to precipitation. So again, this time of year, we can certainly take a look at the impacts, but it may not be terribly relevant. What certainly is relevant is to take a look at the crop condition reports. And so the CropProphet yield model has a component that is based on the crop condition reports, in particular, the percent of good to excellent in every report within the states. And so we always examine these reports because they contain relevant information about what the outcome might be in terms of yields. What's been in the news is that Iowa for corn was quite high. So we see a 98. So in this case, we're looking at the percentile of the July 14th report relative to history, relative to the historical reports. And so 98 means the Iowa report was tied for the best crop progress report, crop condition report for this time of year. Michigan we see at 20, so it's near the bottom. And meaning the crop condition in Michigan is relatively poor. And so, again, overall, we see a lot of green on this map. So crop conditions across the Corn Belt on average are relatively high. The national rank, or it's not a rank, the national percentile is 84. So the US corn crop is condition-wise and health-wise is quite strong. And we see the soybean crop is even better. Yesterday, when preparing this, I was sort of noticing the western side of the Mississippi River for soybeans is sort of an impressive set of numbers in terms of the crop condition report percentiles here. So again, the weather is having positive impact on the reports, and therefore undoubtedly it's having a positive impact on yield across the United States for corn and soybeans. So all of that is a long way of saying the yield forecasts have improved over the past 2 and 4 weeks. We see on the 2-week change on the left, the national yield forecast for corn has improved by 2.3 bushels per acre. We see generally positive yield increases, except in the 3 states we've discussed that have had some dryness and some heat. And then in the 4-week change, we also see pretty positive changes, except for 2 states, and Pennsylvania is almost positive. So really, since our last webinar, the weather conditions have turned rather positive. The yield forecast model has responded, and the market is expecting an excellent corn crop and sort of similar results for soybeans as well. So let's take a look at the weather forecast. So this is as of this morning. On the left-hand side is the 1 to 7 day forecast from this morning's ECMWF model, the physical model. And on the right-hand side is the 8 to 14 day forecast. So again, we see continued precipitation as expected across vast portions of the corn and soybean growing areas of the United States. 163% of normal on a corn and soybean production weighted basis. We also see generally cooler than normal temperatures, although with a very sharp gradient across the I states, with warmer than normal temperatures expected in the southern part of the United States. And then we see the emergence of dryness in the 8 to 14 day forecast, although wet still in the northern tier. And most importantly, we see some heat. So this is the maximum temperature forecast. So corn production weighted statistic shows the 8 to 14 day forecast at 5.2 degrees Fahrenheit above normal, with the core of the heat occurring in Kansas. And so really the question is, will that heat occur? And we will talk a little bit about that. So this chart, it turns out, was kind of popular. So this shows the recent weather forecast performance for the ECMWF, the GEFS model, and the GFS. The column in green, or the model in green, ranked first for the statistic. The column in white ranked second, and the column in red was third. Now I have a question for everyone that you won't be able to answer, but who had on their grain trading bingo card that the GFS model was going to be the most accurate temperature forecast for US corn production weighted maximum temperatures this summer? And so again, the normal expectation over a long history of ECMWF forecasts is that it will be the most accurate forecast, but any model can beat any other model in any forecast. And I find it very interesting that the GEFS model for really a long stretch of period here between 40 and 60 days turned out to be more accurate than the ECMWF for this summer. Doesn't mean it's going to repeat next summer, but it has been true so far this summer. What's also particularly interesting about that is the AIFS. So the ECMWF 2 weeks ago released the ensemble version of the AIFS. And so we wanted to show a little bit of the early results from that. And so for US corn production weighted temperatures in the 8 to 14 day forecast, the AIFS model was generally too cold compared to the other models and compared to reality. And then in terms of the 14 day forecast of precipitation, the AIFS was too dry. And so there's a lot of excitement about AI models and the improvements that they're going to bring. But certainly we want to be careful when we're using and make sure that we understand their performance before blindly assuming that they are the best model available. So we did do a survey. It happened to be on X. And given the results that I've just presented, I think the results are kind of interesting. So we asked, what forecast model are you using to forecast weather? So it comes as no surprise that the ECMWF is the most used model. And it comes as a little bit of a surprise that across 99 respondents, 3% are using the GEFS model. Now, we were talking about relatively small improvements in terms of the verification statistics of the GFS relative to the ECMWF, but I'm sure that everyone wants to make sure they're using the best model possible for the decision they have to make. And I think the results that we showed along with this survey says make sure you're being careful when you're using the weather information and using strategies that comprehensively reviews the forecast information available to you. All right, so weather forecast yield impact. So I described in the June webinar that we have a methodology that, given a yield forecast based on weather conditions that have happened up through yesterday, that we can apply the weather forecast to create what we call the weather forecast impacted yield forecast. And it is a way of objectively interpreting the way that the weather forecast might impact the yield forecasts if those weather forecasts become true. And in particular, I also described that we're able to use each ensemble member. So for example, the ECMWF is a 51 ensemble member. So it's 51 equally likely outcomes of the future. What almost everyone shows in terms of the content, and we show it too, is the average of those 51. But the crops respond non-linearly to weather conditions. So we apply the yield model to each of those 51 ensemble members to get a distribution of potential yield outcomes. And so if we look at the weather forecast impact on the corn and soybean yield forecast from this morning, we see the average national change is in both cases a slight decline of minus 0.3 bushels per acre. Now, given the weather conditions that have occurred so far, this change is minor and likely insignificant. But one of the things we also do is we provide a view of what is the worst case scenario. So it's the worst case scenario on the national yield. So what is the biggest decline in the national yield forecast from one of the ECMWF's 51 members? So we'll take a look at this. And so for corn, the national change, the worst case scenario is a decline of minus 2 bushels per acre. And for soybeans, it's minus 0.7 bushels per acre. So earlier in the season, there were some pretty dramatic worst case scenarios. This is not one of them. So again, the yield forecasts today are relatively high. And so national changes on these scales, while not necessarily good for the crop, don't put us into a difficult supply scenario for corn and for soybeans. All right, so we're going to take a look at the long range analysis from the World Climate Service in this case, and we're going to do it slightly differently this time. So we have been watching a particular oceanic sea surface temperature mode called the Northeast Pacific mode, and you can consider the mode or the index to be either positive or negative. And what I'm showing here is when the mode is negative, on average, what is the sea surface temperature anomaly in the Gulf of Alaska, basically. So generally, when the index is negative, sea surface temperatures in the Gulf of Alaska tend to be negative as well, meaning the sea surface temperatures are cooler than what would be normal for a given time of year. Likewise, for a positive index, it tends to be the opposite. So sea surface temperatures tend to be warmer than average. And so the positive index mode, just to highlight, when the water is warmer than normal, the air above it, is warmed, air rises, water eventually condenses out of it, and you get convection because of the warmer sea surface temperatures. And that convection can set up a whole, basically modify the circulation pattern that occurs over the United States. So if we look at when the NPM is positive during July, we see, in this case, we're looking at probabilities, but we see greater chances of cooler than normal temperatures across the Midwest United States. And in terms of precipitation, we see a greater chance of wetter precipitation, wetter than normal precipitation in July across the growing regions of the United States. And so earlier in the season, before corn was even planted, we were looking at the forecast of this index. So this is seasonal climate model forecasts of the NPM index from a data set called Copernicus. The alphabet salad on the left-hand side is different seasonal models provided by different modeling agencies. And we see that in July, the NPM was forecast to be positive. So this is from the April forecast, NPM likely to be positive. We can go to May, July, likely to be positive. And then we can go to June, and again, it remains a positive forecast. So what was interesting about this consistent positive forecast is if we look at what has happened to the NPM index so far, we see that it's sort of bouncing around zero through so far this growing season up through about July 2nd. And so, in my own thing, I was like, well, I guess that NPM forecast is wrong. And we can't really use the NPM index to understand what might be happening. But then just in the last couple of days, the NPM has started to shoot up, and it's decidedly positive. And so the key then is that when the NPM is positive in July, temperatures tend to be cooler than normal across the US, across the growing region of the United States. And so I'm not going to say that the ECMWF model is wrong per se in its 8 to 14 day forecast, but the fact that the NPM is turning positive does suggest that the risk of significant heat before the end of the month should be greatly reduced. And really, we might be seeing the forcing function associated with the NPM is working against the trend that the ECMWF and some of the other models want to go to for the rest of July. And the reason why July ends up being important is because we're gonna finish out the U.S. silking season, and by the time that ends, then the risk of heat, particularly in the northern tier of the Corn Belt, is particularly reducing that risk if the NPM forcing turns the forecast in the other direction. That is all that we have prepared today, and I will say we're going to do another one of these on Wednesday. Or you registered for the earlier ones, you're already on the attendee list. And thank you very much. I hope it has been helpful.